Welcome to another glimpse video where we try to explain the whole chapter in less than 10 minutes. However, today we are willing to make an exception because we are going to learn about pricing options using binomial models. So this is a little bit more complicated. So I'm going to make four or five videos to explain this topic. And I'm going to add examples unlike other videos. Introduction is that we are trying to again suppose that we have a binomial model, a binomial market. When we say that we have a binomial market, means that we have two options. Normally we declare them as up and down, and suppose that in that market we have a risk-free rate which is R, and we also have a share which costs SO. So we're trying to find how much again, so basically at the present, which is time of inception, that's going to be your time is inception. That's going to be your maturity. We normally use maturity, capital T, to declare maturity, meaning that the share which cost SO at present is going to cost S up and S down respectively in maturity, depending on the state. So we say that is binomial, so it will have two states, up and down. So basically, so we say that this market satisfies a non-arbitrage condition if the S down is going to be less than the price of the share at inception. You compound it to maturity. This is going to be maturity, but for relevance, it's going to be maturity, but it can be any time, right? As long as you are looking at binomial models, it can be a small t but greater than t0. So this value, the price of a share compounded to the maturity, is going to also be less than the S up. Equivalently, if we say that this market is again satisfies a non-arbitrage condition, having filled condition number one, we also say that they exist a number q which is in between 0 and 1, such that the value of share at inception compounded to maturity is going to be equals to q times S up plus 1 minus q times S down. So this statement are equivalent. They are mathematically equivalent. I will not try to show the proof for this one, but then they are mathematically equivalent. And this q, we call it artificial probability, actually risk neutral probability. So stick to the term as we use them. So here we are trying to find a strategy so that we can invest in a bond, a risk-free bond, as well as in a share. We are trying to find how many number of bond, which we will declare by A, how many A number of bond, and as well as B number of shares, so that we can find a strategy to find the value of our option. Remember, we are trying to price options, right? So this is going to be the value of an option, so such that the price of an option at an up market is going to be equals to what? So he's going to be equals to A. So this is when we are assuming that the risk-free bond is going to cost you $1, right? So let's say each risk-free bond costs $1. So if each risk-free bond costs $1, it simply means that not necessarily mean, but then the share is going to be A, and then times 1 times, and then you compound the risk-free rate to maturity plus the B of the share, and while the share is up, because we are looking at the up market, right? And then here the down market, again still the same amount of shares, one, which cost again there's the same amount of bond, a amount of bond compound, which cost one, compounded to maturity, plus the B amount of shares going down. So this is going to be for a down market. We will respectively call them U and D from now on. So keep that in mind. So we are trying to find how many, like, A bond should we purchase and B shares should we purchase. Then the number can be positive and negative to show that we are, again, for negative it means that we don't own the asset, we are borrowing it or we are short selling it. Either way, we are trying to find that A and B such that we replicate it, so that we replicate them in such a way that the value of our option at upside is going to be U and at downside is going to be D. And when we work these things down, when we say this equation 1 and equation B, when we subtract them, we get to this point where we say that B is going to be equals to this and A is going to be equals to this. So this is when you just simply subtract equation 1 and equation 2, and you will come to a conclusion that this is the amount of B of shares you should buy, and this is the amount of bonds you should buy, risk-free bonds you should buy. Meaning that in strategy, so your portfolio will have A bond and B shares, right? So anyway, this means that the value of our portfolio at inception, this is inception, is going to be equals to A, right, which is the number of bond times 1. We already know that the bond is 1. There is no need to write it as 1, times B, number of shares, right? And as we work it down, we can simplify it to this form. Right? And by the theorem that we stated above, that if on a binomial market which does not have an arbitrage, one equivalence is that the risk-free rate can be written, again, the value of the asset can be written like this, right? So you can already see that these things look looks very familiar, and we are going to use it in the future. So just keep that in mind. So how do we apply this findings, right? So to apply these findings, you will have to be given the value of your volatility parameter, which is your risk sigma. So to find your upside of the share, you will use this equation, is the value of the share from the previous node multiply by the risk times the square root, again, so it's going to be e to power risk times the square root of the period, and the downside will have a negative. So keep that in mind. They are similar, but one has negative, one has positive. So yeah, I think this is where I will end. So just to recap, right? We tried to find a replication strategy such that we will find the value of an option in both up and down states of the market, because we are using a binomial model. And right now we are stating that the value of a share in an up market is going to cost this much, and that same share in a down state of the market is going to cost this one, right? So we are trying to use this two equation as well as other equations to find the value of our option. I hope this makes sense, and I'm gonna do a couple of examples to solidify this explanation. I'm gonna do 2 more examples to show the value of the asset, and then later on I will do more examples to look at other to look at other parameters. So anyway, I'm gonna stop here. Thank you.